Rom, thank you for making me laugh today. That was funny.
You're welcome.
Any questions from the yeah?
4.
Number 4 is okay. Is this number 4? Is it absolute value of x plus 2? Minus 2? Okay. So let's graph first our parent function. So I'm going to say we're going to graph this in blue. Yep, that's it. So our parent function is going to look like this. Is that okay? So that's this one, the parent function. Being that that's minus 2 and it's grouped, it's going to do the opposite thing. So if it's going to do the opposite thing, what do you feel it should do?
It should go left, I feel like. And it goes
Do the
right.
opposite.
It goes right.
So this is what this looks like. Okay? When it's grouped, it will shift the opposite direction that you think.
Wait, do you have to do the parent function?
I want you to. The important thing about the parent function is by you doing that, you're able to show what the actual graph is doing.
Okay.
And so, just so you all know, the parent function, when you graph it, and there's things that we defined yesterday that were fantastic. Like out in front is our a value, which is like our slope. Okay, so our parent function starts here, rows up 1, right 1, left 1, up 1, and it creates this v. So that's what the parent function looks like. The important thing is when you are able to show your graph, if you have the parent function on that, you can really see where it shifts right or left easily. ROM.
What do you call this equation?
Absolute value. It's absolute value. And again, the parent function is the most basic form of the absolute value it could be. Like there's, the equation y equals x is the most basic linear equation. It's the one that goes right through the origin at a 45-degree angle. Yeah.
When are we going to start using the A?
Say that one more time. Oh, the a value? Today we'll actually focus a little bit on it with our notes. Is that all right?
Isn't it on the back side of the homework?
There was 6 slides that I didn't get to, and I don't think we're really going to hit. So I ran out of time yesterday, and I was looking at them, and I don't think we don't necessarily need them. And okay, David says here, remember, bring your pink ballet shoes home. Okay. All right, so was there any other questions from 1 through 6 on there? So, yeah. Number 6. Okay, so number 6, I'll just do it right here. F of x is equal to the absolute value of what? X plus 6, is that what it is?
Yeah.
Like that? Is that it? Oh, wait, number 6?
Oh, just kidding. Oh, I did the one in the workbook.
Oh, okay. Well, while it's up there, what do you think? Where's it going to shift to? It's going to go back 6. So 1, 2, 3, 4, 5, 6. Way over here. So this one looks like that. Okay, so the whole thing shifted over. So again, if it's grouped, it shifts the opposite of what you would think it would do. If it's not grouped, it shifts up or down. You okay about this? Any others? Are you okay with the shift and the up-down shift? Did both? Do I see it?
5.
5? Can you tell me what number 5 says, please?
H parentheses x equals x plus 4 and then minus 4.
Like that?
Yeah.
Okay. So this is going to take it left, and this is going to take it down. Is that right? So let's graph the parent function. looks like that. And then it's going to shift left 4. So 1, 2, 3, 4. And then it's going to shift down 4. It's still going to grow at a rate of 1 to 1. That's it. Okay. And again, guys and girls, these properties that are taking place when it's grouped are the same properties that happen on any graph. Okay? And that's kind of nice. There's consistency. It's not like, oh, well, now we have something that's raised to the 3rd power with all the different rules apply. No, it's the exact same rules over and over. And the reason we go with absolute values is because we just stopped with linear equations. An absolute value graph is basically 2 linear equations that have the same starting point and go in other directions. You okay? You all right? Happy? Sad? Okay. Let me hand out to you next set of notes. And what I'll do is tomorrow during class I will spot check off what today's was, so make sure you have that. And then, so what was due today, what we just talked about, so there's a few others that you haven't seen. And then I will go over the one that's bringing with this, which is also the same that's in the book, I believe. But I think the book got goofed up on the graph, so we reprinted it so you have a graph to actually look at. Yeah. Oh, right up on the board.
Bad boy.
Bad boy.
Bad boy.
Okay. So graphing linear equations, number 9b. Graphing absolute value functions. So I think we're going to do a little bit more of this. Again, the parent function, the big key on this, guys and girls, and I can't emphasize it enough, and I know that, you know, at your age, it's like, well, why should I put extra? You got to trust me on this one. It will pay off for you in the end because it shows an awful lot of understanding of how the shifting works of graphs. You put the parent function. In this we just have the parent function of absolute value, but there'll be more. So let's think about this. Let's go and how do the values of A, H, and K affect the graph? Okay, so the H value shifts it right when it's negative, and it shifts it left when it's positive, right? Correct? That's what we learned yesterday, right? And then here, the K value, it shifts it up or down. So it shifts up when it's positive, and then it shifts down when it's negative,
Yes.
right? Is that right? What you got?
You spelled something wrong.
I guess you guys are paying attention to what I read. Oh. Yeah.
I'm definitely gonna watch this video.
Yeah, in about 9 minutes in, you're gonna. Sorry about that. Shoot. to change words or something. Boy, whew, sorry about that. I didn't mean to put something bad up there. Boy, oh. Yeah.
Like on this video.
Get my act together? I will.
Abby, shut up.
All right. So, hey, an innocent mistake doesn't have to turn into something bad. It happens. Okay, that A value we talked about yesterday. We didn't really work on it yesterday on the assignment, but what did the A value do to the absolute value graph itself? It makes it more thicker, thin, fat, or skinny, right? So, large A value makes skinny an A value between 0 and 1 makes it fatter. Okay? Now, a value between 0 and 1 means there's a fraction. So like 1/2 or 3/4 or 5/16 or something like that. That makes it fatter. Okay? It compresses it vertically is what it's actually doing. And then the A value being a large value. Now, can an A value be a large value that's a fraction? Yeah, like we had 10/3, that's 3 1/3. That's a pretty big value. That's going to make it stretch vertically. Okay? Now, there's one other thing the A value could do. What could it do? Nope, I'm not going to distribute it over the parentheses. But what do you think that A value would do? One last function. It is the slope.
You can make the graph larger if it like.
Okay, we got
into the old slope equation.
So this can make it real skinny like this, and this can make it real fat like this. But there's one other thing the A value could do. Yeah. Flips it upside down. Good deal.
Oh.
Okay. And then the one last value is if you have a negative A, it flips over. So it makes it go downward. Is that okay? So there's basically three things. Now, we're not going to really go back to it, not too much, but there is one other property that does take place, and it's right in front of that. And that actually has something to do with the horizontal stretching and compressing. Unfortunately, it's hard to see a horizontal stretch or compress because a lot of times it looks just like vertical. So, so this let's do this. Let's see if we can make this work. If I go like this is vertical stretching, but it's also horizontal compressing. Looks the same, right? If I go this way, it's vertical compression, but horizontal stretch. So it's hard to see it on this type of graph what that value does. So I don't need to make a lot of time on it, but there is something called a horizontal stretch and compression. It has to do with the term that is right before the x, if it's a numeric value, so between there. Yeah?
Okay, so with the A, is it possible to have like a 180-degree line or like a completely vertical line?
I guess as that A value gets very close to infinity, the absolute value graph actually comes to a straight line. But that's actually a really big question. That's beyond calculus question. It has to do with something called the central limits theorem. As something approaches something else, what happens to the graph? That's a great thought, and I like it. And that's something that you're going to see later in math. Not this math class, but later math classes down the road, but that's a great thing to think about. I like it. Good, keen observation there, sir. All right, can I move on? All right, so work with a partner. Let's not work with a partner. I'm your partner for now. Okay. What does letter A's graph, what does this resemble?
Parent
The
function.
parent function. So which one of those
Two.
appears to be the parent function?
2.
The parent function goes right one, up one, correct?
Yep.
So right here, right one, up one. So does everyone feel that this could be A?
Yep.
And for sake of colors, we'll see what we can do. Bless you. What about this one? What do we feel this one might do? Let's use some verbiage that I just talked about. What is this going to do?
Up to and over 1.
Up to and over one. So it's making it fatter or skinnier?
Skinnier.
Skinnier. So it's doing a vertical
Stretching.
Stretch.
Horizontal compression.
So this is a not horizontal compression at this point because that has to be in front of the x inside of the bracket.
It's 3 because you have to flip it.
Okay.
Why?
So B, we went up 2, right 1. Is this it?
Yep. Yeah.
This is letter B.
See, it's not. Wait, how is that? Because you don't. It's not negative.
It goes up to.
Right,
Goes
wrong.
over
I
1.
got it.
Okay.
Ooh, okay. Someone feeling feisty today?
All right. Letter C.
You smell the salt?
Letter
Salt in
C.
the air?
Letter C. What do you think? What's some things you notice about it? It looks like a parent function, but what does it do?
Flipped over.
Flips it.
Is that because it's negative?
Because that negative flips it over. So this is going to go right 1, down 1. That might work.
Wait, down.
Or is this one?
No, it's
Right
that
on.
one.
That one's
Number
like
3.
No, it's that one.
Oh, there you go. So down 1, right 1.
That's not right.
Kind of like-
That's right. It's not. Yes, it is.
Okay. The reason it's not going to be 6, we're going to see that in a second. This is opening down, but this is going down 1, 2, 3, right 1. Okay. So let's focus on this one. What is this one going to do?
It's gonna make it skinnier.
It's going to make it skinnier, so it's a vertical
Stretchy.
stretch, and so it's going to be triple the height real quick. So this is going to go triple the height. So 1, 2, 3, right 1.
Yeah.
That it?
I like this color.
Okay. And the green one. So it's
Opposite.
what's definitely something you know.
It's negative.
It's negative, so it's going to open downward, and it's going to be triple. So this one, I'm going to go from here. I'm going to go down 1, 2, 3, right 1, or 1, 2, 3, left 1. So this is letter E. Is that all right? And then, obviously, we're going to be able to figure out.
No, do the pink strip. Yeah,
Do
down.
the brown
No,
one.
go up and click the pink strip. The pink dot one and then
That one?
yeah.
All right.
Look how pretty.
All right. So let's think about this one. It's opening up. It's between 0 and 1. So is it a vertical stretch?
No.
It's a vertical
compression.
compression. So this one is going to go up 1, right 2. Up 1, right 2. Up 1, left 2.
Wait, I have a question.
Yeah.
Wouldn't it be like you do your dots half?
So
So could you just like cut it each three in half?
So think about a slope. Rise over run. Up 1, right 2. If this is 1/5, it would go up 1, right 5. Okay? So we got some nice colors, I think. Those of you who can't distinguish the difference between green and red, C and E look like the exact same line.
I'm colorblind.
Okay, sorry.
The pink is confusing. The lines aren't close.
Gotcha. All right. So the vertex is HK, and the slope is basically our A value. So things that we need to know about our slope is if we had something like this, okay, and I know that's a little different, but meaning like if our A value was a fraction, it's going to go up / down. If it was positive up, negative down, and then this is going to go right and left.
What?
Now the reason I say right and left is because if I go up 1, right 2, I go up 1, left 2 as well. Does that make sense?
Yeah.
And then what do you notice about the two lines from all of the previous graphs? They are symmetric about each other, meaning there's a vertical line that could act like a mirror, and we could fold the paper over that vertical line, and the two graphs would fall right on top of each other. Yeah?
Would you determine, like, with negatives if it goes right or left for the denominator?
So the denominator will go up and then right and then up and left, or it'll go down and right and down and left. So the right and left do take place because it's a graph doing this, so you go both directions. Does that make sense? All right. So core concept: the vertex of an absolute value function. The absolute value function is written as that, where the a value is not equal to 0, is in vertex form. The vertex is hk. So the vertex is the place that you're changing direction. It changes from, switches right or left. The graph comes down and then hits it and then goes back up, or it comes up and then hits it and goes down. So that's where we change direction. And then we have symmetry that does take place. And remember, x equals a number. X equals a number is a vertical line. It's an undefined line, undefined slope line, but it makes the symmetry about our object so we can fold it over it. Okay, graph each function compared to the graph of f of x. So the first thing I want to do is I'm going to plot this first. What is that plotted? What is that called? The parent function, okay? So now let's figure out what this is going to do. We'll do this one in green. What's it going to do? What is that? It's going to go up 2 and... Okay, so it's going to start here, and it's going to go up 2 and right 1, and... So it's a little bit skinnier. Right? Correct?
Yeah.
A little bit skinnier. Yeah.
So if it's negative, then it'll be the same thing.
Absolutely. Okay? So let's draw the parent function one more time here. Actually, let's do this. Okay? Parent function. Up 1, right 1, up 1, right 1.
Yes.
Or up 1, left 1, up 1, left 1. Correct?
Correct.
So, what is... I wonder if I can change color on that. What is this one going to do?
Up 1 over 2. Make it fast.
Up 1 over 2. Up 1 over 2. Up 1 over the other 2. Straight 2. Look at that. So that picture shows us a lot of information. It shows us that we have an understanding of the parent function, and it also shows that we have an understanding of what the compression would take place, or on the first one, the stretch would be taking place. Feel okay? Huh. What's that? I heard a question. The half? It actually offers a horizontal compression, which would make the graph like this. So it's a lot harder to identify that a horizontal compression in this case. The only place that I have seen that horizontal compressions are understandable is, you know what the graph of a sine graph looks like?
No.
So it looks like this. A sine graph looks like this in a cheap version. If you had your xy axis, the sine graph looks like this. And it keeps going. Okay?
A wave.
Like a wave, yeah. And so this is function at x is equal to sine at x, which that's a couple math classes from now where you have to worry about that. But what happens with this is if you start getting a number right here, it does this to it. It like stretches it out a long way. But if you had a number here, this either makes it taller or shorter, depending upon what the number is there. So that's a good place where you would see a vertical stretch or compression and a horizontal stretch and compression acting together. But it's not something that you're not going to have to worry about. This, I mean, trigonometry is a beautiful math. It's like my favorite math in the world, next to statistics. I love it. It relates to everything. And like you can apply it to everything. Like the sunrise, it applies to that. Of course, daylight saving time screws things up. But if you lived in Arizona, you could plot all the times the sun comes up in the morning throughout the year, and it's a sine wave. It's beautiful. Yeah. Can I make that a graph? Yes. Yes. There is, under one of the modes, this. I think it's under the math edit mode or math. Under the math key, and then there's an ABS key that it works on.
Are we gonna be actually graphing for calculators?
One of these days I'll do it. Yeah.
What's after algebra 1?
Geometry. No, I love it.
Wait, everyone's telling me that geometry is the same thing as algebra 1, but it has proofs.
So we take a break?
CP. No, you do a lot of algebra in geometry. Geometry is beautiful. It's a beautiful math as well. It's almost as beautiful as algebra.
Which is not beautiful.
All right. Here we go. Let's make our parent function. Parent function, yes? So what is this going to do? What's it going to do? It's going to make it go down. Is it growing at the same rate but just going down?
Whoa, those are cool lines.
Because I use the straight edge tool.
Just so you did it by hand.
All right, so why did that flip it upside down? What value is negative? The A value is negative. Okay? Number 4, let's draw the parent function. Let's draw the parent function. Parent function. What do you think? What's it going to do?
It's gonna go up to down.
So it does what?
Up 2 over what? -3 is gonna.
What is this? That means it's going to grow faster, so it's skinnier. What does that do?
Up 2 right 3.
What's it down 3?
Down 3. So it starts down here. It grows up 1. It grows up 1 and it grows up 2 and over 1, right? And then here. So the whole thing shifted down because of the minus. It became skinnier, double skinny, because of how it grew. It grew up 2, right 1, up, and then up 2, right 1. Okay? So this one shifted down because of the minus outside, and then it grew skinnier. Can I move on? All right, so we have this. So we have a few things that are going to take place with this. So I want to graph the parent function first. Graph the parent function. Here's the parent function. Is that okay? All right, so let's list what this is doing. Shift. Let's talk about the up or down first. Does it shift up or down?
Yes, it does. Shifts up.
Shifts up. How many?
3.
Everyone okay with that?
Yes.
What's another shift we know?
It goes right 1.
Shifts
Right, what?
right
Why
1.
is it shifting right 1? 'Cause the 1
Take a look. The 1 is part of the group, so it does the opposite.
And then it makes it skinnier but flips it over.
Yeah, it's
And
gonna
it's
flip it
negative
down.
as well, so it'll shift.
Okay? So then So it flips down and grows at a rate, grows down to, and then both right and left, 1. Is that everything? Okay, so I want to put a dot where I think the vertex is going to be. Where do you think the vertex is going to be? The parent function vertex is at 0, 0. Where's this vertex going to be? 1, 3, 1, 3. So at 1, 3. At 1, 1, 2, 3. There's my vertex. It's going to open down. It's going to grow a rate of down 2 and right, left 1. Make sense? So from here, I'm going to go from this dot. It's going to go down how many? 2 and right 1. Does that work? Let's see. Down 2, right 1. Is that right? And then down 2, right 1. There you go. What do you think? Do you agree with all the shifting?
Kind of. Yeah.
Spelling shift with an F?
I do have a question.
Yeah.
Could you like draw in new lines that like have a dot at every 2? Or is that not
Help me out. I don't know what you're saying.
like okay, so if you draw a new axis and then you do every 2 you make like a dot on the line.
Oh, I think I know what you're saying. So perhaps something like this. Down 2, right 1. Let's make it green. Down 2, right 1. Like that.
Like okay, if you draw like axes at that the point, like the first point. Yeah. And then you put a dot every 2. And then never mind.
Okay. I'm sorry. All right. How are we doing on these notes? Where are we at? We still have more left?
We have a lot more left.
We have a lot more left? Are
Not
you?
really, we just got the graphics.
We have a whole page of graphs.
All right. So, number 6. Compare the graphs. Compare the graphs. So let's graph our parent function first. So I'm drawing this parent function. Is that okay? Is that okay?
Yes.
Okay. So let's think about what is this graph going to be doing?
It shifts down. No, it shifts right 1.
Shifts right 1. So it's here. So I'm going to go this way and up, and this way and up. What is this one going to do?
It's gonna do the same thing,
But
it's fatter because
Fatter.
it's a 1/2
cool. So it's going to be still here. So I'm going to go up 1 and
over 2.
right 2. And up 1 and over 2. So the green's our parent function. The purple is our one that shifts to the right. Our blue is the one that shifts to the right and is fatter. All right? Okay, let's talk about this next one. Okay, I'm going to draw the parent function in blue. So the graph and the parent function are the same color. We good? So what is this graph going to do? Up 2 and left 2 as well? So it's going to go up 2. So our vertex is like right here. And this is still going to grow at a rate of over 1. And then if this came up a little bit, up 1, over 1, up 1. So that's what this graph's doing. So this shifted left 2, up 2. What is this one going to do? So what's one of the shifts?
Up 2.
Up 2. What's another shift?
Over left.
Left 2.
And then go down
Up.
4 over 1.
And then, oh, it's going to go down there. Okay, so I'm going to go down 1, 2, 3, 4. Is that okay? And I'm going to go from there to right 1 and left 1. What do you think? Did I do okay on those? Bless you. So let's talk real quick that line of symmetry. A vertical line, if I drew a vertical line right here, I could fold the red over top of it or right over top of this. So there's a vertical line that takes place. The vertical line with the parent function happens to be the y-axis. All right? Oh, sweet. All right. So, attached is the worksheet. I believe on the worksheet. So, what I want to make sure you have on the worksheet is, see on number 1 how I have drawn in the parent function? I want to make sure you draw in the parent function on all of those graphs and then do this shift around graph. Does that make sense?
Yeah.
And if you trust me on drawing the parent function in, I promise you, the things that are later to come are going to make so much more sense. As long as you realize I have a parent function there, and that's what this is doing. Oh, look, I have a new function, and this is what's taking place. And the parent function is still on there. Cool? Feel okay?